do it that way, but that's not really what the approach that we're taking here, okay? So let's just say we have this graph right here, and this is f of x, okay? And I want to make a graph of f prime of x, which means I want my y values on this graph, this second graph here, to be the slope values of this original graph. Okay, if I'm graphing f prime, I'm graphing the slope values as y values over there. Okay, so let's just look at this real quick. What can we see about the slope over here on this left side of this graph? What can we say about the slope here? The graph is going down. That means the slope is negative. Now, the slope is negative right here. Is it getting more or less negative as we go? More. It's actually getting less negative because it's flattening out. Okay? So the slope is very steep negative where we start, and then it's flattening out. So it's still negative all the way till we get to here, but it's flattening out, so it's getting less negative. Okay? Now, we're going to graph those actual slope values as y values over here. Now, it doesn't have to be exact. There's just certain things that have to match. Okay? So we said the slope's negative, so I'm going to start down here. It's getting less negative, so it must be going up. Now, what happens at 0 here? What's the slope right here at 0? The slope is 0, which means this y value has to be 0. So that has to cross the x-axis right there.
Which is a straight line?
Yeah, it's going to be a straight line. For this one. It's not always, okay? Now, what happens after we cross 0 over here? What happens to the slope? They become positive and they get more and more positive, right? So that just keeps going up like that, okay? So yeah, you can think of it that way. If you have a parabola that's x squared, the derivative of it would be 2x, and that would be a line, right, with a slope of 2. So you can think of it that way. Now, but we're not going to just be dealing with parabolas, so I want you to be able to do it straight from the graph, okay?
How about double prime?
Okay, that's a good question. So if we were doing if we were going to graph the derivative of that,
that's why you straight line horizontal line.
Yeah, this would be the slope of this line is always the same, right? It has the same slope the whole time. I mean, in this case, if we said that was x squared over there, this would be a slope of 2. So this would be a horizontal line at 2. What if we kept going? What's the slope of this line? 0 always. And it'd be 0 every time after that. Okay.
I have a great riddle for that.
Okay. So you guys, I want to make a quick list of rules to use for this. Okay. So 1, the derivative has one less term. This is for polynomials, okay? That's not the case for all functions, but for polynomials, that's what we're looking at right now. The derivative has one less term because the exponent goes down by 1, right? So you're going to have one less term on the graph. Now, this is real important right here, okay? Max and min on f. Max and min on f are x-intercepts on f prime. And this kind of has to do with what we just talked about with horizontal tangents. Okay? Because a max or a min on f has a horizontal tangent, which means that the derivative has to be 0, which means that on the graph, the derivative crosses the x-axis. Okay? Now, this goes both ways, and we're going to do this both ways, okay? Now you want to differentiate between the max and the min, all right? So if we go back, let me go back to this graph real quick. Over here, this parabola has a min here, right? The slopes are changing from negative to positive, which means this graph is changing from negative to positive across the x-axis. Okay, that creates a min. If this was a max over here, the slopes would be positive and then negative. So that tells you the direction that you're going to cross the x-axis. Okay? So a max on f crosses positive to negative on F prime. Okay, and a min on F crosses negative to positive on F prime. And of course we're always reading in what direction? Left to right. Okay, so that's important. That's important for this. When we say cross is positive to negative, we're talking about from left to right. So that's like this. If we're talking about negative to positive, we're talking about like this. Okay, that's how it crosses the x-axis on the derivative graph. Okay, and then these, it goes the other way too. So we're gonna, I have a worksheet for you that I'm gonna pass out, and then, or actually I'm gonna have you guys really pass these out, and we're gonna, we're gonna do one of these together. Okay, we're gonna do the second one together.
Wait until we all pass them.
Yeah, speed up on that.
Yeah.
Okay, now, so this worksheet has 4 problems on it, okay? 1, 2, 3, 4. What?
If you hold it hot dog style or
Go back.
hamburger style.
I like how you have to use it.
Okay, so we have you're given the middle one, you're given the F prime. So you have to go and do F, you have to do the derivative of that to get F double prime. You have to go the other way. It's called the antiderivative, okay, to get the original function F, okay? So I'm going to go ahead and do the second line here, all right? So this middle graph, this F prime graph, looks like we have we're crossing here at -3, and we have a max at -2, and then we're crossing back through at, well, that's not very good, through at -1. We have a min here at 1, and then we're crossing here at 2. Okay? So we're going to go down first and do the derivative of that first, and then we'll go up the other way. Okay?
I didn't forget.
Okay.
Wait, where are you?
Hold on a second. Who didn't get one? Okay. So let's see, -1, -2, -3, 1, 2, 3. All right. So you guys, when you're graphing these, listen. The y values don't really matter. What's important is that you have the right thing there at the x values that are important. So we're going to take these maxes and mins here. We're going to take this max. This max is at -2. All right. That means, I'm going to change colors here. This max here is at -2. That means at -2 on the derivative, we have to cross the x-axis. It's a max, so we have to cross from positive to negative. So I'm going to just draw a little piece in there.
On the F
On this,
prime.
yeah, this is F prime, so this is F double prime. That just means the derivative of F prime, right? Don't worry too much. It's not we're not going straight from F to F double prime. Okay, so there's a max there, so we cross positive to negative. Now there's a min here at 1, so this derivative graph has to cross from negative to positive at 1, and that's all there is. So then you connect those. Okay, it doesn't matter. It doesn't have to be exact what you draw in between, but
It's a curve.
right. So now look, on this graph we have 2 turns, right? On this graph we have 1 turn, which is what should happen. Okay, because that's the derivative. A cubic is going to turn into a parabola on its derivative. Okay. Now, any questions on that? Okay. So maxes and mins turn into x-intercepts when you're going down.
So minimums go left to right. Maximum, like, minimums go negative positive.
Right. Yeah. Maximums go positive, negative. Okay. So let's go the other way now. Okay. Now, so when we're going this way, max mins become x-intercepts. Okay, when we're going this way, x-intercepts yeah, become max mins. Alright, so where are my x-intercepts here? I have an x-intercept at -3, right? It's going from negative to positive. That means over here I have a min. Okay? Let me put some marks in there. Okay, so if x-intercepts become max or mins when you're going this way, you got to decide which one it is. This is going from negative to positive at -3. That means at -3 I have a min. I'm just going to draw one in there. It doesn't matter where it is on the y. You could draw it up here, you could draw it in the middle, you could draw it anywhere. There just has to be a min at -3. Okay? Next time we cross is at -1, which is going to be a max because this is crossing from positive to negative. That means at -1 we're going to put a max in. Again, it doesn't matter how high or low you put it, it just has to be there as a max. Alright? And then at the next time we cross here is at +2, and that is going to be what? That's going to be another min because it's crossing negative to positive. Okay, so at +2 we have a min. And then you connect them. Now at the edges, it's going to keep going straight in whatever direction it ends up in. Okay? Now that has how many terms I just drew? 1, 2, 3, and it should, right? Because if we go derivative from there, that would have 2 terms.
So now we can do reverse derivatives.
Yes. So what?
We can now do reverse derivatives.
Yeah, you can graph them, and you'll learn next year how to actually do them with equations. But
So the y value, but wouldn't the y value still matter? Because
no.
it matters.
No, and the y value doesn't matter because when you're going this way, because what happens to any constant when you do a derivative?
Yeah, it cancels out.
It drops out. So you don't know. This could have had a +10 on it. It could have had a -8 on it, and that changes the vertical shift. So this could be up or down anyway. Okay, what matters is you get these maxes and mins in the right spot for now.
From the
Okay.
right x.
Yeah, the right x spot. The x spot is what matters here. The y doesn't. Okay? All right.
We get counted off.